Good morning, dear students. Today I am trying to give you an idea about three main concepts related to current electricity. They are current, potential difference, and resistance. As we all know, the movement of charges causes current. In metals, the moving charges are free electrons, and in electrolytes, the moving charges are positive and negative ions. The charge in motion constitute electric current. So we can define the electric current as the rate of flow of charge, or it is the amount of charge flowing per second through the cross section of a conductor. Hence, current can be written as total charge by total time. The symbol of current is I, so I is equal to Q by T, where Q is the charge and T is the time. Now, let us see what is the unit of current. The unit of current is equal to unit of charge by unit of time. The SI unit of charge is coulomb and SI unit of time is second. So, unit of current can be written as coulomb per second. This coulomb per second is termed as ampere. So, the unit of current is ampere, which is equal to coulomb per second. Now, 1 ampere is equal to 1 coulomb by 1 second. So, if the charge is 1 coulomb and the time is 1 second, then the current will be 1 ampere. That is 1 coulomb by 1 second is 1 ampere. So, 1 ampere can be defined as the current flows when 1 coulomb charge passes in 1 second. The smaller unit of current is milliampere. The prefix milli means 10 raised to minus 3. So, 1 milliampere is 10 raised to minus 3 ampere. And the another smaller unit is microampere. Micro is 10 raised to minus 6. So, it is 10 raised to minus 6 ampere. So, we know that the charge of 1 electron is 1.6 into 10 raised to minus 19 coulomb. So, 1.6 into 10 raised to minus 19 coulomb charge passes when 1 electron passes through a conductor. So, if it is 2 electrons, it is 2 into 1.6 into 10 raised to minus 19 coulomb. If n electron passes, the charge flow is equal to n into 1.6 into 10 raised to minus 19 coulomb. That 1.6 into 10 raised to minus 19 is charge of 1 electron, so it can be taken as E. Therefore, the charge is equal to n into E, where E is the value 1.6 into 10 raised to minus 19 coulomb. It needs 6.25 into 10 raised to 18 electrons to produce 1 coulomb charge. That means when 1 ampere current passes through a conductor, there is a passage of 6.25 into 10 raised to 18 electrons. So, 1 ampere can also be defined as the current flows through a conductor when 6.25 into 10 raised to 18 electron passes in 1 second. The current is always opposite to the direction of flow of electron. Now, let us move to the next concept, which is called potential or potential difference. Before that, I'll give you some examples. Here we can see a body which is released from a height. It always moves down because it is always moving from higher level A to lower level B, that is from higher gravitational potential to lower gravitational potential. Now, there are two vessels A and B containing water up to certain level, and the level of water is different and the vessels are connected. So, the water flows from vessel A containing water at higher level to vessel B containing water at lower level due to difference in hydrostatic pressure. That means it is not the amount of water but the level of water decides the flow of water. Similarly, if two bodies A and B at different temperatures are brought into contact by conduction, Heat flows from the body A at higher temperature to the body B at a lower temperature till both the bodies A and B acquires the same temperature. Here also it is not the amount of heat but the temperature decides the direction of flow of heat. In the same way, if two charged bodies are connected together, the charges will flow from negatively charged conductor to the positively charged conductor, because negatively charged means there is excess of electrons and positively charged means there is deficit of electron. That means the charge flows from more concentration of electrons to less concentration of electrons, and the current is always opposite to the direction of flow of electron. Hence the current flows from positive charge to negative charge. Hence we can say that the positively charged body is at higher potential and the negatively charged body is at lower potential. So electric current flows from a region of higher potential to a region of lower potential, that is in a direction opposite to the direction of flow of electrons. The movement of electrons continues as long as there is a difference in potential between two conductors. Hence, to get a continuous flow of current between two conductors, a constant difference in potential has to be maintained between two conductors. We have already know that like charges repels each other while unlike charges attracts each other. Hence, if a charge is brought nearer to another like charge, some work has to be done in moving the charge against the repulsive force on it due to the other charge. Therefore, quantitatively, potential can be defined as the amount of work done in bringing a unit positive charge from zero potential to a point. Zero potential is at infinity, so it can be defined as the work done in bringing a charge from infinity to that point. So potential is equal to work by charge. So the unit of potential is unit of work by unit of charge, that is joule per coulomb. This joule per coulomb is termed as volt. So the unit of electric potential is volt, and 1 volt can be defined as the potential at a point when 1 joule work is done in bringing 1 coulomb charge from infinity to that point. But in practice, when we consider the flow of current through a conductor, we consider the flow of charge only between 2 points. So, the potential between 2 points is termed as potential difference, or potential difference is equal to the work done in moving a unit positive charge from one point to another. The unit of potential difference is also volt, and it is expressed as the amount of work done in moving 1 coulomb charge from one point to another. Now let us come to the third concept, which is resistance. Even for a good conductor, it offers some obstruction to the flow of current. This obstruction offered to the flow of current by a conductor is called resistance. So let us think about the reason of resistance. In metals, there are so many free electrons and which are in random motion due to the less attractive force with the nucleus. But when the ends of a metal wire is connected to a cell, we are providing a potential difference. Hence, the electrons inside it start moving from one end to the other end, or from negative potential to positive potential, and hence the current is from positive potential to negative potential. During their movement, they collide with the fixed positive ions. Hence, the speed of electrons decreases. Due to this collision, the speed of electrons decreases, but again they are accelerated due to the existing potential, and at last they reaches to the other end. So due to this collision, the speed of electrons decreases and the electrons do not move in bulk with a continuous increase in speed. But there is a drift of electron towards the positive terminal and it is offered as resistance. Hence, the resistance of a conductor depends on the number of collisions suffered by the electrons with the positive ions. Now let us see the factors affecting resistance. There are 4 factors that affect resistance. The first one is nature of the conductor. The second is length of the conductor. The third is thickness of the conductor. And the fourth is temperature of the conductor. Different substances are having different concentration of free electrons. Therefore, the resistance of the conductor depends on material. A good conductor offers less resistance and a bad conductor offers more resistance. Now, in a long conductor, the number of collisions will be more as compared to shorter one. Therefore, long conductor offers more resistance than a short conductor. In a thick conductor, the electrons get a larger area of cross-section. Since it is thick, their cross-sectional area is more. Hence, electrons get a larger area of cross-section to flow from one point to other. Hence, thick conductor offers less resistance and thin conductor offers more resistance. At last, the temperature. The temperature increases the kinetic energy of the molecule. So, the positive ions will start vibrating. Due to the vibration, the chance of collision increases. Hence, the resistance of the conductor increases with increase in temperature. These are the main concepts related to current electricity. Thank you.